Fellow of the Academy of Sciences Malaysia, friends from media, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. I would like to extend a warm welcome to everyone for your presence this morning at the Intellectual Discourse, Green Opportunities in the Rare Earth Industries, organized by the Academy of Sciences Malaysia. Without further ado, I would like to invite Yang Berbahagia, Academician Datuk Engineer Lee Cheong, Senior Fellow of the Academy of Sciences Malaysia, to deliver his welcoming address and to moderate the session. Dipersilakan, Datuk.
Good morning, everyone. Maybe I just take 2 seconds to introduce myself. Actually, my biodata is in your program. I just want to know that my background is electrical power engineering. But since about 25 years ago, I have retired from engineering and have been engaged in very unusual non-engineering activities. So my present preoccupation, I'm following 2 gurus. One guru is Professor Jeffrey Sachs, who is the UN Secretary General Special Representative on the Millennium Development Goals. So I'm following him in poverty eradication in Africa. The other guru that I follow is Dr. Rajendra Pachauri, the chairman of the Intergovernmental Panel on Climate Change, IPCC, that won the Nobel Peace Prize. So I follow him on climate change. So I'm, in a way, an activist. So I understand the frustration of activists. That's why I'm asked to chair this. And also, I'm very pleased this morning that we have participation from academia, from our own fellow of the academy, but also from academia, young students and researchers. Because I was telling them that actually what we are discussing here is for them, not for old people like us. So I'm very pleased that they are here. And of course, they are also, I want to welcome the NGOs that have been with us since Monday. And I actually thank them very much for their dedication to whatever their belief. I think it's important that if we believe something sincerely, that we hold on to our belief. Okay? I want to just tell you that, of course, you have got copies of the study report by the ASM and the National Professorial Council. And this 3 days event, starting from last Monday, was a result of the follow-up action arising out of the study report. And we thought that in the follow-up action, we need to introduce the world of rare earth to Malaysia. That Malaysia is not so preoccupied just with Linus Geping and then, Mount Well, Western Australia, and maybe because you heard about the dominant position of China, some reference to China, but rare earth has been going on throughout the world for quite some time, and there's now a resurgence. But I will leave it to our distinguished speaker to guide you through the rare earth. So of the 4 speakers here, actually except for Mr. Neil, the other 3 are first-time visitors to Malaysia. They only arrived on Sunday morning. So I welcome them actually to Malaysia. But the other thing is that after the Monday seminar, yesterday they went to Kuantan and Geping. So they visited the Linus facility, but also they visited the University Malaysia Pahang. I would like them this morning to also, in their presentation, to say a few words about their impression of their visit yesterday. It was a very tiring visit. Actually, we worked them too hard. We never allowed them to have any time to see a bit of Malaysia at leisure. Although I think the drive to Kuantan and back you did manage to see a bit of the countryside. So I do not want to take up too much of the time, but I would like to suggest that we change the program today. That means instead of having an hour of question and answer at the end, that after every presentation, we should have the Q&A. Because at the end, if you know, after the 4 speakers make their presentation, maybe the Q&A is very, very diffused and not focused. So I would like to, to suggest that the 1 hour Q&A at the end, we split it 15 minutes at the end of each presentation by every speaker. Is that okay with you? Okay, so then I will just go on to the first speaker. The first speaker is Mr. Jack Lifton. Now you have Lifton, you have got his CVs also in the program. But I just want to say that he is a founding principal of the Technology Metals Research. And then he is a gentleman who coined the phrase strategic material. And he is actually an acknowledged expert on rare earth and other strategic material. And he actually told me that he is a chemical engineer by training. So without further ado, I will welcome Jack to the podium. Thank you, Jack.
So first turn to the errata page and I will correct a couple of mistakes. One, I coined the phrase technology metals, okay? And I'm a chemical engineer for 50 years. And I first worked with rare earths, as a matter of fact, 50 years ago when in the private company I worked in, we had to actually separate and purify small quantities ourselves because there was no one to do it. And I needed neodymium and it wasn't available. So I probably spent the equivalent of thousands of dollars a gram making a few grams. I don't remember. All right, first thing I'd like to say is that I have never seen a rare earth separation plant of that size and so well designed and constructed in my life. That was a phenomenon. I talk all the time. I was silent. I didn't know what to think. And every question I asked was answered. And it made me think of the philosopher who wrote in 1812, if reasoning doesn't have numbers or magnitudes, cast it into the flames because it's sophistry and illusion. I didn't see anything remotely dangerous or unsafe. I saw a place where there were triple safeguards. I owned a company, chemical engineering company, in the United States. I'm telling you honestly, sometimes I was afraid to go in my own company, depending on who was doing what. So this was to me a giant size laboratory. And I'm familiar with all the components of it, and I saw redundancies, safety redundancies over and over again. And in our visit, these gentlemen were speaking endlessly about what I am telling you is trivial amounts of danger. When you chlorinate water, you get chlorinated organic chemicals. These are known carcinogens. So do we not chlorinate water? No, because we quantify the risk. The risk is very small. Right. In my opinion, and I'm going to tell you already your answer to my next statement, so I'll be sarcastic. Of course, there's no problem for me. I'm going back to Michigan. Okay? But there's also no problem for you. The problem here is very simple in Malaysia. That plant is your gateway to the 21st century high technology. If you don't open that plant, you're remaining in the 20th century or farther back. Keep in mind that other nations which are just as concerned with the health of their people want that plant desperately. They want this kind of business. In this morning's paper, I noticed an article about the European company Bose, B-O-S-E. This is the premier maker of loudspeaker in the world. Okay. In January, I spoke at the Loudspeaker Manufacturers Association meeting in Las Vegas, and my topic was, is there enough neodymium? So what is that about? Well, it turns out that Bose and the American company Harman and some Japanese companies, among them produce 600 million loudspeakers a year for the automotive industry. 600 million. 70% of them are made with rare neodymium iron boron ring-shaped magnets. So even if the speaker on your GPS is small, that's 500 million of them. The speaker on your the big speaker on your car is not so small. And I asked them, why do you do that? And I knew the answer. The answer is to reduce weight and increase fuel efficiency and make the car greener. That's what that's about. As I'm sure there are many engineers and scientists in the room, and as you know, if you make magnets out of iron, ferrite magnets, they're at least in volume as much as 100 to 1,000 times larger than neodymium iron boron. The purpose of using neodymium iron boron or samarium cobalt is miniaturization, reduction of size without sacrificing efficiency, power, etc. When I saw the story about Bose coming here, I mentioned it to a colleague, and he said, oh, well, this is a low labor cost place. I said, I don't think so. Yes, it's you're lower labor cost than Germany, or the States perhaps, but it's not such a low labor. So what's the reason? Well, the reason is to have access to the raw material. Where's that going to come from? It's going to come from that Linus plant. I guarantee you one thing. If the Linus plant doesn't open, you can say goodbye to Bose. They won't open either. And the point is, the output of the Linus plant, I calculated yesterday from what I was told, I'd say between $400 million and $800 million a year of revenue. I'm looking at a gentleman who knows more about it than I do. That's $100 neodymium, okay? And that will multiply itself, as the economists like to say, by a factor of 10, 20, in this country I'm talking about. It's unmeasurable. If you say to me, I can't make a car without rare earth permanent magnet motors, generators, loudspeakers, power steering, sensors, wheel sensors, then you're telling me that the several $100s of rare earth magnets in a car, if you don't have it, you don't make the $30,000, $40,000, $50,000 car. Well, that may be true, because in competitive business, efficiency and green is very important. I'm the official speaker for the Society of Automotive Engineers about rare earths. That's I said. There's one of us, me. Okay. The thing that we realize is that you can't substitute for these things. They're going to be with us permanently. The other thing, this is some good numbers for you to remember. First of all, I see people here that are in their 20s. You will not live long enough to see electric cars take more than 10% of the market. They are not economical, and in the end, economics is the driver for this world. You are now able to produce, I can buy, if I have the money in the US, a Volkswagen Passat turbo diesel, 4-cylinder engine, 51 miles to the US gallon. That's pretty good. And if, as an American, I have to have power windows, power seats, a moon roof, GPS, and everything else, because that's, you can't live without that. If you actually make a car for the purpose of getting from one place to another, you can get a 75-mile-an-hour car because half the weight of the junk will be gone. Okay? I'm talking internal combustion engine fueled with gasoline, fueled with kerosene, fueled with natural gas of any type. If those cars, of which today on this planet 750 million vehicles, cars and trucks, are now on the roads of the world, 275 million in the United States. It's predicted in 2020 they'll be on the road about 1,200,000,000 cars. Each car, if it's an internal combustion engine, will use 0.43 kilograms, 430 grams of rare earth metals. Of that 430 grams, 63% will be neodymium, and right now it's believed 12% will be dysprosium. Okay, now, so you're saying, well, half a kilo, a pound in each car, how much is that? That's 750 million pounds tied up. You can't have it back. I have to get to the shop to buy some milk. You can't have it. It's gone. You need to, for the next cars and the replacement cars, because we're recycling very little of this material, you might think about that, you're going to need more and more of this material. Now, what happens if the problems of battery storage are solved? As you know, the problem of battery storage is one of cost efficiency. I cannot afford a $15,000 battery in a $25,000 car. Okay, so until that's resolved, we're not going to be doing that. Plus, the nickel metal hydride battery made with lanthanum nickel hydride, the rare earth metal lanthanum, put out by Toyota in 1997 as the best, as twice as good as a lead acid battery. That's why they did that. I was involved. Now it's 15 years later, and they're still using them. And the joke is, they last 8, 10, 12 years. They're extremely reliable. None of them has ever blown up or caught fire. Okay? And so I believe Toyota built a plant in Vietnam to recycle the batteries, somewhere in Southeast Asia. And that plant has grass growing in it because they couldn't get enough feedstock of their own batteries. These are very successful, very successful. A Toyota Prius with a nickel metal hydride battery of 1.5 kilowatt hours gets 51 miles to the US gallon in the combined operation of internal combustion and electric. Okay. Why do you want to improve on that? I'm not here to argue about global warming. I know nothing about it. Climate change, I know nothing about it. What I'm telling you is that you're not going to take 750 million cars away from 1.5 billion or 2 billion people who use them. If you go electric, congratulations, that's nice. Now you need to multiply the number of rare earths you need by 7. The average design we see in the U.S. of an electric or hybrid vehicle using, let's say, lithium-ion battery, is 3.5 kilograms per unit of rare earth metal, 7 times as much. Now, some of my colleagues know all these numbers, and they can tell you that isn't going to happen for a simple reason: there isn't 7 times as much material ever going to be available. All right, what's that got to do with here? In my opinion, if this plant gets a permit, because it's ready, but of course it needs feedstock and it needs to run. Okay. When it's running and it's up to capacity, Malaysia will be the world's second largest supplier of rare earths. Now, I admit that the distance from Chinese supply to Malaysian supply is rather a large one. Chinese supply would be at that time 120 or 30,000 tons. Malaysian will be 20,000 tons. That is not an insignificant number. And I'm not going to discuss today, there's an American plant, it's planned to be gigantic and everything. You can, if that happens, fine. This plant is ready. So, quite frankly, obviously I don't know anything about your local politics. You can tomorrow be the second largest rare earth supplier. Now, what's going to happen if that happens? Nobody's a real good salesman, no matter what you think. So even if the Linus people think they've sold all their output, I guarantee you that they haven't. There have got to be entrepreneurial Malaysian people who say, you know what, if I can get that stuff, I could make some of those things here. For example, I guarantee you that Malaysian cars are made with Chinese magnets or Japanese magnets, of course. So why not make them here? Well, it's going to be cost, isn't it? Why does everybody go to China to manufacture goods containing rare earths? Because that's where the rare earths are. Okay? So when the rare earths are here, they're going to come here. And as I mentioned, Bose is planning to open a plant here to make loudspeakers and audio equipment. Why? Because they're going to make the magnets themselves. And they're going, I haven't been told this, I know nothing about the business operations of Linus, the financial operations, but I'm going to have to guess they have a deal with Bose. Because Bose is going to invest a huge amount of money here, and they're not doing it on speculation. Governments do things on speculation, private industry does not. So I'm expecting Malaysia to become a big center of rare earth permanent magnet manufacturing. Again, I make a joke. China produces 75% of the rare earth magnets, Japan 25%, and the rest of the world the balance. Okay, that is the magnet production. But it's a lot of jobs here, and you have the raw material. I was discussing this the last 3 days. You've got a lot more rare earths here than you think. But it's up to you to find them. You have spent a century here concentrating rare earths, and I'm very surprised you're not processing them. Okay, but I'm sure my colleagues don't like it when I say this, so I'll say it. I predict that within 3 years of the Linus plant operating at capacity, when it's staffed with Malaysian engineers and scientists, that someone will decide he's going to move to another place and build a smaller one and make a business and another business and another business, and then what happens is you have a dynamic business. Now that's what's going to happen. I've been doing this a long time. I spent 20 years in East Europe. I saw no entrepreneurial spirit in East Europe whatsoever, either before or after the fall of the Soviet Union. Nobody cared. That is not the case here. There's a lot of entrepreneurial spirit. When we stopped at the university, I was shocked by the quality of the equipment. Okay? I'm familiar with all the equipment I saw, and it was the latest, and I said, so do you have a department of rare earth studies? Well, no, but that's why my colleague, Dr. Yang, and his colleague from Germany are here. Both of their universities are planning to have exchange programs with the Malaysian universities to create programs for the study of the engineering research of the properties of the rare earths. This is an ideal place to do that. And you will find, I was told on Monday that many years ago when Malaysia was a tin mining center, Malaysian engineers went all over the world to teach people in Brazil or Congo how to mine and smelt tin. Okay, so that was the past. I'm predicting Malaysian scientists and engineers will go around the world to teach people how to process rare earths. And I will make you a bet that happens 5 years from now. And there'll be PhDs in this country studying rare earths in China with Dr. Yan, coming back to Malaysia and teaching here and starting industry here. So the only thing I want to say is that it's your choice. You can stay in the 20th century, be happy, okay? 60 or 70, 85% of my life was spent in the 20th century. I don't expect to spend that much in the 21st. Okay, so for me, I'm watching. I don't care anymore about money. I can't remember what last time I chased women, okay? I don't drink or smoke. So what do I do? I'm interested in rare earths and rare metals, and I invented the term technology metals because somebody said, what category do all these metals for electronics and go into? Nobody had I said, we'll call it technology metals, and it stuck. Okay. I want you to succeed. I want you know, I've never been here before. And I was shocked, not by tall, but every city in the world to me looks alike. It's all tall buildings, all that. But beautiful roads, electricity everywhere, things that you're now taking for granted. But in no disrespect, in places like this, it wasn't so obvious 50 years ago. I was born in 1940. In my lifetime, there was no electricity in the state of Tennessee. Okay? I remember the box with ice for storing the food, not an electric refrigerator. I remember horses delivering milk on my street in Detroit. The United States is not, it wasn't born as a great industrial technical power. Neither was Malaysia. But I'll tell you this, Malaysia is moving faster towards becoming an industrial technical nation than the United States ever did. And I'm very impressed. Thank you.
Q&A, because then the question and answer will be more focused. So now I would like to open the floor and invite question. Please, when you ask a question or comment, try to be short and concise, but also give your name and affiliation. Thank you. Anyone want to start? Come on, this is a hot topic, you know. Please.
Thank you, Mr. Chairman. Can you press? Actually, I'm Dr. Lifton from Design Malaysia, from School of Material and Mineral Resources Engineering. We offer courses in the starting utility and hydrometallurgy for more than 10 years. See, what is opportunity for us? That's from the academician in future to get involved in the because our country don't have much that kind of this mineral that bearing minerals. Last time it's a monazite and the xenogene, zircon and so on. But nowadays I used to involve in the AIST, Academic Institute of Science and Technology of Japan. I got some grant last time to looking for the ionization type of this records type of the tool for the area resource. So I think what we can do here in Malaysia, because we don't have that so much resource. Because even we claim we got 0.03% of records is from the most of tin tailings, from the tin mine. Actually, now we run out of this resource because we got more than 25 grants, and it's very concise. So, for the Linus type of ore is a science we don't have here. So what this industry can offer actually from the Benin set for the academics to actually for those mineralogy to get involved in this research. It's better to have in Malaysia.
In the United States, there are in the U.S., there are 2 schools left of metallurgical engineering for mining. 2. I know the entire faculty in America of this subject, both men. The world needs this technology and this specialty. If you never work a day in Malaysia, you'll work everywhere else in the world where they're developing this. There is a real shortage. What I see over and over again is engineers from mining talking to me about things that are 50 years out of date. That's how we do it. I have a little game, I say. If it's not sulfuric acid, hydrochloric acid, or sodium hydroxide, it doesn't exist. I don't know about it. And there is such a world of opportunity. I was told here by a gentleman who I believe the other day, a distinguished academic, that I was talking to him about something like Oppurtunities. I said, the Brazilians have given up on cracking cassiterite residue. They can't do it, it's too refractory. He said, oh, we did it 30 years ago. I said, so why don't you send some people there to be paid to show the Brazilians how to do it? Or even better yet, do it here and tell them about it in television or electrical. Okay? Do it. You couldn't have picked a better profession. If I told you how much they're paying people in that profession in Canada, you'd be at the airport today.
Dr. Fadil may would like to comment on our resources.
Yeah. Our riots are actually tied up with the tin mining industry. When the tin industry took a downturn, naturally our sources of monazite and xylitol also fell drastically. Now, if we want to have more monazite and xylitol, we have to revitalize our tin industry. And one way we are going about is to look at how we can revitalize our rare earth industry, which is tied up with the tin industry. And once we're able to convince the state governments there's a potential in the future, and with this Linus plant that has come up, we have nothing to do with the Linus plant. We just want to revitalize our tin mining industry with which all the rare earths are covered. And I heard from Jack just now that we should also look at our tin residues which come out from our tin smelters. They also probably carry rare earths. We know it carries tantalum and niobium. We've been recovering that and exporting it. But maybe it's worth a while getting our smelters to look at rare earths within the residues. Maybe USM can do it.
Jack, I would like to just ask you that can we see that every country is conserving their natural resources and using others first. So we, having been mining economy, depending on tin, but also iron ore, right? Quite small. But I was thinking whether we should not actually do mapping, and not just about rare earth or tin, but all other mineral resources that we might have.
I would think that's a very good idea. You should first. I know every nation is doing what I'm about to tell you, and I always thought they did it in my grandfather's time. They never did. They're counting their resources. They're trying to find out what they have, and it has not been done. Most of every nation has not been explored by geologists, exploration geologists. You don't know what you've got here. What I know, and you know as scientists, is that if there's tin, all the metals associated with tin must be nearby. Okay, but what you said is very important. The Western world, because it has been totally ignorant of resource utilization, we don't care. A typical buyer in a company in America will say, oh, I need rare earths, give me the phone. I'll call the guy, and then the phone book, it says rare earths. That's how they do it. Or China's taking a different course. China is looking to conserve resources for its own development. When we do that in the U.S., we call that good policy. When China does it, we call it policy against us. Okay. Now, every nation is doing that. You need to find what resources you have, conserve them, be careful, recycle, close the loop as much as possible. And you can do all of that. In the past, it was not economical to recycle small quantities of exotic metals. Now, because of other larger flows, for example, in the past we didn't collect consumer scrap. It just, I don't know about here in America, it just went out the door. Okay. Now everyone's collecting this material. In Japan, they told me if we process process 630 million cell phones. We recover 50 kilo gallium, 50 kilo. So we don't do it, it's not economical. But when we speak of some other metals, everybody is silent. There is value added. And you work out first the economics, then the security. I'm not talking military. I'm talking security of your economy, industry. In America, we've actually determined what metals we need to make sure that our industry continues to be independent. Same with Europe. There's 40 metals the European Union has chosen as strategic. They mean that without them, some European industry will be unable to function. Both the US, Europe, and Japan have lists. They differ just a little. All the lists include all of the rare earths. Keep that in mind. Because modern electronics, any device to transform electricity into motion, motion to electricity, electricity to heat or light, is today using a rare earth permanent magnet or rare earth metal, like neodymium in a laser. You don't realize how much you depend on these rather rare materials. They're not rare in nature, they're very difficult to obtain, practically economically. So, first, survey the country. And by the way, the best way to do that, go to the old records from 100 years ago. It's called data mining, okay? And then see what you can produce here, and then calculate what you need to produce to maintain your style of living and to increase it for everybody. Because I believe that's what China is doing right now. And that's going to be the model of the world.
Mr. Chairman, sorry to delay and miss the substantial substance of your presentation.
Let us know who you are.
I'm Hashim from the Academy of Sciences. At the tail end of that presentation, I heard you say that Malaysia is rich with rare earth sort of product here. Now, with that information, do we need to import? Maybe companies need to import rare earth from outside? So that's my question.
I'm going to guess that you don't have enough light for rare earths. Yeah, I would rather that Alice
two things. One is to bring a mine into production is 5 years, typically at minimum. First of all, you have to find it. The other thing is no two rare earth deposits are the same. And the biggest challenge in rare earths is the metallurgy to break down the basic ore. And the process varies from deposit to deposit. Also, the facility that's set up in Kuantan is specific to the deposit that they are bringing in. If you were to find a different type of deposit that was more skewed to what we call heavy rare earths, they would have to redesign the plant entirely. So I think, unless you find another bastosite deposit in Malaysia, a mine, you're not going to open up a mine unless it has a 10-year mine life. This facility in Kuantan is slated to run 22,000 tons a year. So you're going to have to find a deposit of minimum 250,000 tons of rare earths of bastosite grade to be able to go and not import material.
Can I just add that the chances of finding a bastosite deposit in Malaysia are not there. We don't have the geology to support that. Our rare earths would be from monazite and xenotime tied up with granites, which is with the tin mining industry. At the moment, we don't produce much tin, less than 3,000 tons a year now. We used to produce about 80,000 tons. That time we had a very vibrant tin mining industry and a lot of amma, a lot of monazite and xenotime. And we had a cracking industry also processing, but then they ran into some trouble. Prices of monazite, rare earths came down. This is all cyclical. Now rare earths are in such great demand and there are very, very few deposits in the world. China is the main supplier, and Mount Mel in Australia, maybe Molycorp in time to come. That's about all we are playing with. And should we find a deposit, another 5 years, but it's tied up with tin mining. And it's up to the state governments in this country whether they want to open up the area to for tin mining. If they don't, we won't get very much. So that's the situation.
Any other question? Yes, sir.
Thank you, Jack, for highlighting us on the potential and possibility of downstream industry. And I like your statement. It's our choice whether to get stuck in the middle or we move up to the 21st century. Now, my question is that the potential of downstream industry, do you think it will trade off, it compensate with all these tax exemptions that the company is enjoying for the next 20 years? So these are the issues that people have been asking. Thank you.
So what? Repeat the question.
The question is,
essential question.
Is the tax exemption enjoyed by the company for the next 20 years, will that be compensated by the possibility of downstream industries that will be here maybe for the next 50 or 100 years?
You know, I always hear about things that take a long time, and so it's too late. Was it too late 10 years ago? Just, if you do it, so you start. Okay, and what's interesting to me is nobody is thinking economics here. Okay, there's no pesticide mountain in Malaysia, but, okay. Have you thought to put together some capital and go and buy it in another country nearby? Okay, that's the answer. You know, the United States is a bad role model for the world economically because North America is one of the richest places that we have every resource. Of course, we don't produce them, but we have them. But it's a mature economy. We don't need to be bringing in giant copper mines in America. We have sufficient, and we don't have an export mentality in the U.S. So there's plenty of minerals in Southeast Asia. People want to sell them. So what Malaysian entrepreneur can buy a mine, bring concentrates to Malaysia to process and make high-value end products. That sounds like something I've heard yesterday from an Australian company. Because you may think Linus is an Australian company, but all they do there is the same as in the Congo. They mine. The intellectual addition is in Malaysia. Think about it.
Can I ask backbenchers to my left or my right? Please, backbenchers, any comments or questions? What about? Oh yeah, please, thank you. You please move down.
I'm so I just want to relate my experience in terms of the rare earth mineral supply initiative. Okay, previously in the 80s we have around 28 amount plants. These are the physical mineral treatment plants where they separate the individual minerals. And of late we have only 5 from 28. Now it become 5 because one of the things that we have a declining in terms of the tin mining activity. But last year, I was called by a businessman from Japan. He won a very large quantity of imports of monazite from Malaysia. So he asked me, please give me the 5 treatment plants that you have so as that you can get all the monazite from Malaysia. But I only know one company. So I gave him that particular company. And in turn, he replied to me that, oh, it's enough. That one company can supply all his needs. So the thing here is that our treatment plants actually are very, very sophisticated and highly tech. And it doesn't depend only on our local tin mines. They are actually importing these heavy minerals from China, from Indonesia, from Thailand, from elsewhere, and process it locally. And also they are actually now giving their know-how to countries in South America, how to separate the individual minerals. So you can see that our rare earth minerals does not only depend on the thin mining of our local deposit, it also depends from overseas.
So anyway, Dr. Mio has moved from the back bench to the front bench. I still want, questions and comments from the back benches. Oh yeah, please, from the media.
Yeah, hi.
Can you please, maybe, microphone? Okay, thank you.
I'm Pei from the Night Graph. I would like to move here. Yeah.
Yeah. From the middle bench, go to the back bench.
I would like to ask about Molycorp. There's quite a large rare earth ore in California, if I'm not mistaken. So, why was America so dependent on China for rare earth supply? Why didn't it process its own rare earth since it has its own rare earth ore?
Economics. I remember at the end of the 90s, it became cheaper to buy Chinese rare earths in Los Angeles than Molycorp rare earths, which were a 3-hour drive from Los Angeles. It's all about economics. I don't know how much it costs to produce a kilo of rare earth in China, but the selling price is the issue. Everybody is confused. They're worried about how much it costs. It's the selling price. I could buy rare earth in America cheaper from imports and by the way, in its great wisdom, the American government put tax on imported rare earths when we weren't producing any. Okay? This was, to me, the highlight of government. So we had 5% duty on the material, and it wasn't enough. China still would be cheaper. I can't tell you how China achieved that. I have never visited a Chinese mine because it's normal. Have you? Okay, then good.
I can answer that a little bit. I used to sell against Molycorp. They were one of our competitors. But Molycorp had a mining mentality, and they made a very low quality, unsophisticated product in most cases for catalysts. And really didn't go up the value chain to high quality, high tech type materials. So, they were great to compete against. But, when I started in '95, you could sell cerium for $12 a kilogram. By 1999, that was down to $4 or $5. So the Chinese basically, at that time, it was a very unregulated industry. You had a lot of mom and pop type operations. Like seriously, I've been in these plants where it looked like something out of the Industrial Revolution. And they would run it when they could make money, and then they'd shut it down and go back to the fields when they couldn't, depending on the price. So it got to the point where Molycorp couldn't be competitive. And they've always talked about coming back to the market, but it hasn't been until the last 2 or 3 years that the pricing has got to a point where it's economical for them to consider going back into production. And that's, at the end of the day, you need to make a dollar or a ringgit or whatever it is, and if you can't do that, there's no sense opening the doors.
Yes, Obama.
Okay, thank you very much, Dato'. Actually, the issue before us is, do we invest in rare earth? Because we have heard from the international experts, there are opportunities because of the growing demand for rare earth minerals, but there are risks. There are risks involved. Now, if Malaysia really is interested to go into the rare earth, to build the rare earth industry, we cannot do it alone. Malaysia has no access to the market, have no understanding about the trade, the technology. We cannot do it alone. We have to partner. Right. So, we have to look for suitable partners. But why should investors come to Malaysia if we don't have the rare earths and we don't have the market?
also no man.
And no human capital. So these are things we need to consider. So the question before us now, do we want to invest in this opportunity or not? If we want to invest, we have to look at the risk. We have to partner with companies who are more familiar with the market, with the technology. That is the way to go forward. I again like to cite an example of the oleochemical industry. When we started, we have a lot of palm oil, but I wanted to go downstream. We had no access to market, we don't have technology, so we partnered with all the big guns in oleochemicals. But now, after 20 years, we have companies which are 100% Malaysian. So this is the way to go if we are really interested. So this is actually the question before us. Thank you.
While we all ponder what Dr. Marcus posed, can I ask you to give a big hand to Jack?